Punycode is a way to represent Unicode with a limited character subset of ASCII supported by the domain name system. For example, ma 1/4 nchen would be encoded as mnchen3. Punycode is intended for the encoding of labels in the Internationalized Domain Names in Applications framework, such that these domain names may be represented in the ASCII character set allowed in the domain name system of the Internet. The encoding syntax is defined in IETF document RFC 3492. The IDNA methodology encodes only select label components of domain names with a procedure called to ASCII. The procedure to Unicode decodes the DNS label into Unicode representation. In computing, Punycode is an instance of a general encoding syntax by which a string of Unicode characters is transformed uniquely and reversibly into a smaller, restricted character set. Encoding procedure. This section demonstrates the procedure for Punycode encoding, using the example of the string bar 1/4 share, which is translated into the label bcheakvar. Equals separation of ASCII characters equals, first, all basic ASCII characters in the string are copied from input to output, skipping over any other characters. For example, bar 1/4 share is copied to bcher. If any characters were not copied, an ASCII hyphen is added to the output next. Since it is a basic character, the ASCII hyphen may itself appear in the string before this additional character. However, the additional ASCII hyphen does not cause any ambiguity as no later part of the encoding process can introduce another ASCII hyphen. The last ASCII hyphen, if any, signifies the end of the basic characters. Equals encoding of non-ASCII character insertions as code numbers equals. The next part of the encoding process first requires an understanding of the decoder, which is a finite state machine with two state variables I and n. I is an index into the string ranging from 0 to the current length of the extended string. I starts at 0, and n starts at 128. The state progression is a monotonic function. A state change either increments I or, if I is at its maximum, resets I to 0 and increments n by 1, then goes back to incrementing I in the following state change. At each state change either the code point denoted by n is inserted or it is not inserted. The code numbers generated by the encoder represent how many possibilities the decoder should skip before an insertion is made. A 1/4 has code point 252. So before we get to the possibility of inserting a 1/4 in position 1, it is necessary to skip over 6 potential insertions of each of the 124 preceding non-ASCII code points and 1 possible insertion of code point 252. That is why it is necessary to tell the decoder to skip a total of +1 equals 745 possible insertions before getting to the one required. Equals re-encoding of code numbers as ASCII sequences equals. Punycode uses generalized variable length integers to represent these values. For example, this is how kvar is used to represent the code number 745. A number system with little endian ordering is used, which allows variable length codes without separate delimiters. A digit lower than a threshold value marks that it is the most significant digit, hence the end of the number. The threshold value depends on the position in the number and also on previous insertions, to increase efficiency. Correspondingly, the weights of the digits vary. In this case, a number system with 36 digits is used, with the case-insensitive A through Z equal to the number 0 through 25, and 0 through 9 equal to 26 through 35. Thus kvar corresponds to 10-21-0. To decode this string of digits, the threshold starts out as 1 and the weight is 1. The first digit is the units digit. 10 with a weight of 1 equals 10. After this, the threshold value is adjusted. For the sake of simplicity, let's assume it is now 2. The second digit has a weight of 36 minus the previous threshold value, in this case, 35. Therefore the sum of the first two digits is 10, 1 plus 21, 35. Since the second digit is not less than the threshold value of 2, there is more to come. The weight for the third digit is the previous weight times 36 minus the new threshold value. 35, 34. The third digit in this example is 0, which is less than 2, meaning that it is the last part of the number. Therefore kvar represents the number 10, 1 plus 21, 35 plus 0, 35, 34 equals 745. The threshold itself is determined by an algorithm keeping it between 1 and 26 inclusive, meaning the last character of an encoding will always be alphabetic. The case can then be used to provide information about the original case of the string. For the insertion of a second special character in bar 1/4 share, the first possibility is bar 1/4 or 1/4 share with code bche the second bar 1/4 car 1/4 her with code bche vab, etc. After bar 1/4 share a 1/4 with code bche becomes a 1/2 bar 1/4 share with code bche vaf, etc. To make the encoding and decoding algorithm simple, no attempt has been made to prevent some encoded values from encoding inadmissible Unicode values, however, these should be checked for and detected during decoding. Punycode is designed to work across all scripts, and to be self-optimizing by attempting to adapt to the character set ranges within the string as it operates. It is optimized for the case where the string is composed of 0 or more ASCII characters and in addition characters from only one other script system, but will cope with any arbitrary Unicode string. Note that for DNS use, the domain name string is assumed to have been normalized using nameprop and filtered against an officially registered language table before being punycoded, and that the DNS protocol sets limits on the acceptable lengths of the output Punycode string. See also, host name. References. External links, IETF Punycode Standard, ICU IDNA demonstration and online demonstration of how ICU performs IDN operations, list of TLDs considered by the Mozilla developers to have an effective anti-spoofing policy for name registration, IDN and Punycode in IE7, simple Punycode converter, online on-the-fly Punycode converter based on the Punycode JS JavaScript library.